Properties of matter can be categorized as either being physical properties or chemical properties. Physical properties of matter are those properties that can be observed without changing the chemical makeup of that substance, without converting that substance into something else. For example, when you look at water, we know that at a room temperature, it's a liquid. That's its physical property, because to make that observation, I did not have to change its chemical identity, or that ice is less dense than water. Once again, it is simply observed but without having to change the chemical identity of either of the substances. The fact that sugar is soluble in water once again describes its physical property of sugar, because when sugar dissolves in water, sugar stays as sugar and water stays as water. They just mix very uniformly with each other. The fact that banana is sweet, a ripe banana is sweet, again, that's its physical property, because banana didn't change into something else. But however, here, this is a very complex example that I gave, because my determination of the sweetness may be a chemical process that's happening in my mouth within my taste buds. But as far as the property of banana is concerned, that is its physical property. How about water freezes at 0 degrees Celsius? Once again, it's its physical property. Without having to change water into something different than water, we can make that observation. So any property that can be determined, that can be observed without changing the substance into something else, is called its physical property. Chemical property, on the other hand, are the ability or the inability of a substance to change into something else. For example, iron rusts outside in air and water. That's its chemical property, because iron gets converted into iron oxide, which is commonly known as rust. Fuel that you pump into your cars is flammable. That's a chemical property of the fuel, because when the fuel burns, it creates new substances that did not exist before. The fuel gets completely consumed in that process, chemically consumed in that process, to make new chemicals, new substances. There are lots of such processes. Cooking is a chemical process where substances are changing their chemical makeups, and those properties are called chemical properties. So once again, physical properties are those that can be observed without changing the chemical identity of the substance. Chemical properties, on the other hand, are the inability or the inability of a substance to be transformed into something else. Similarly, matter can undergo two different kinds of processes, two different kinds of changes: physical changes or chemical changes. Physical changes, as you might guess, are the changes that do not change the chemical makeup of the substance. All the phase changes, melting, evaporation, boiling, freezing, sublimation, distillation, condensation, whenever any of the physical changes, whenever any of the changes in the physical state of matter happen, those are physical changes, because when those happen, the substance stays as such. When water freezes, it's still water. The individual particle present in liquid water is exactly the same as that in solid water or in water vapor when the water evaporates. So the chemical nature of each individual particle does not change. It's just the physical state. What changes is the forces that are holding those particles together that change. Dissolving, let's say, sugar in water is again a physical process, because when you dissolve substance A into substance B, neither of the two substances change in their chemical identity. Do a very simple experiment. Go ahead, pause the recording and do a very simple experiment. Take a glass of water, a spoonful of salt, and add the two together and stir them up. What you will hopefully get is this clear colorless liquid that looks just like water. You probably can't see salt anymore. If you do see salt, maybe you need more stirring, or maybe you need more water in there. Go ahead, try it out. Once you have that mixture of salt and water, dip your finger in it and taste that. Does it taste salty? Yes, it does, because salt is still there as salt. Does this mixture look like water? Yes, it does, because water is still there. So neither salt nor water changed in their chemical makeup. What did happen is that individual particles of salt and water uniformly mixed with each other. So dissolving is a physical process between the two substances that are dissolving. Fogging of the windows, precipitation in the sense like rain or snow, those are all physical processes. Chemical process, on the other hand, is a process that does bring about a change in the chemical makeup of the substance. In a chemical process, substances are used up and new substances are created in their place. Things that didn't exist before are now present. That's a chemical process. Burning is a chemical process. If you cook, you're carrying out chemical processes all the time. Digesting food in your body is a chemical process. Respiration in our body is a chemical process. Rust, when iron rusts, it's a chemical process. Fermentation, when wine is made from grapes, that's a chemical process. If you leave milk out on the kitchen counter for a few days in the summer, the milk curdles. It spoils. Basically, what you will see is those white chunky pieces in there. Hopefully you don't put that in your tea or coffee, but that's a chemical process because you created something that was not there before. Perming your hair is a chemical process. When you get a cut and you bleed, and after a few minutes the blood coagulates on the surface, that's a chemical process as well. So, as a summary, processes that do not change the chemical identity of substances are physical processes, whereas those that do change the chemical identity are called chemical processes.